Hello everyone, my name is Rena Belton, and today my group will be presenting about the quality assurance and control for ABC Electronics. And my group members are Yovenswari, Adriel, Benson, and Susmita. So before we start, I would like to talk about the background of study for ABC Electronics. ABC Electronics is a consumer electronic manufacturer that produces smartphones. Recently, the company received a high number of battery-related complaints for a new smartphone model. The main issues reported were battery overheating and fast battery drain, which negatively affected user experience and product reliability. As a result, this defect led to an increase in product returns and warranty costs for the company. Therefore, quality improvement measures are required to identify the cause of this battery performance issues and to reduce future defects.
Hi, my name is Yunisri Naidu. My entry number is 2213417879. So my part is about problem statement. ABC Electronic is a consumer electronic manufacturer that produces smartphone and tablet. So it's recently that company has faced significant increase in customer complaint related to battery performance in their latest smartphone model, which are battery overheating occur when the smartphone battery generates excessive heat during charging or usage. This can be caused by poor battery quality, faulty charging circuit, and poor heat dissipation. So overheating is a serious issue because it can damage internal components, reduce battery life, and pose safety risks such as burns and fire hazard. This problem lead to customer dissatisfaction and safety concern. Fast battery drain means the battery loses power quickly even with the normal usage. This indicates low battery capacity, poor battery chemistry, or inefficient power management. Customers experience shorter usage time and need to charge their phones frequently. This problem affects user convenience and reduces the perceived quality of the smartphone. Charging failure happens when the battery does not charge properly or stop charging completely. This can be due to unstable charging circuit, damaged charging pad, or internal battery defect. When the phone cannot be charged, it becomes unusable, leading to product return and increased warranty claim. Battery swelling occurs when gas builds up inside the battery due to chemical reaction, often caused by overheating, overcharging, or low quality battery material. A swollen battery can deform the phone casing and damage internal part. This is a critical safety issue because it can lead to leakage or battery explosion if not addressed. Physical damage include dents, crack, or deformation of the battery, usually caused by improper handling during manufacturing, storage, or transportation. Damaged battery may not function properly and can lead to performance issue or safety risk. This indicate weakness in handling procedure and quality inspection processes. So, in conclusion, this battery-related problem significantly affect product performance, customer satisfaction, and company cost, highlighting the need for effective quality control and process improvement. Thank you. This section of the poster presents the check sheet, which is a basic quality control tool used for systematic data collection. The check sheet was used to record different types of smartphone battery defect identified during daily inspection over a period of 5 days. Each time a specific defect was observed, it was marked in the check sheet, allowing the team to track the frequency of defect type. Defect categories recorded include battery overheating, fast battery drain, battery swelling, charging failure, and physical damage. By summarizing the data across 5 days, the check sheet clearly shows that battery overheating and fast battery drain occur most frequently compared to other defects. This organized data collection provides a reliable foundation for further analysis using other quality control tools such as Pareto chart, histogram, and control chart each of defect type.
Hi, I'm Sushmita Ravichandran. My metric number is 2213418876. So after collecting battery defect data using a check sheet, the next step in our quality control approach is to prioritize the defects that contribute most significantly to the overall problem. This prioritization is important because addressing every defect at the same time is neither practical or efficient. To achieve this, a Pareto chart was constructed. In this Pareto chart, the x-axis shows the difference different types of battery defects, while y-axis represents the number of defects recorded. The bars are arranged from highest to lowest frequency. In addition to the bars, a cumulative percentage line is included and plotted on the right vertical axis. This line allows us to see how the contribution of each defect accumulates towards the number of defects. From the chart, battery overheating is identified as the most frequent defect, with 33 recorded cases accounting for approximately 33% of the total defects. The second most frequent defect is fast battery drain, with 28 cases and contributing about 28%. When these two combine, they account for more than 60% of all battery related defects. This means that a majority of quality issues experienced by customers are associated with just these two defect types. Other defects such as battery swelling, charging failure and physical damage contribute smaller percentage individually. While these defects are important, addressing battery overheating first is expected to yield greatest overall improvement. This finding aligns with the Pareto principle, which suggests that a small number of causes are responsible for most problems. Based on this analysis, battery overheating was selected as a critical defect for further investigation. After identifying battery overheating as the major effect, the next step was to analyze battery performance variance using a histogram. This histogram represents the distribution of smartphone battery capacity values measured in milliampere to hours. The horizontal axis, x-axis, shows battery capacity ranges, while the y-axis shows the number of smartphones that fall within each range. From the histogram, we can observe that battery capacity is not evenly distributed across all units. While most batteries fall within the central capacity range, some units show noticeably lower or higher capacity values. This variance indicates inconsistency in battery performance, which can affect how heat is generated and dissipated during smartphone operation. Batteries with lower effective capacity may be subjected to higher stress during usage, while batteries with higher capacity may generate more heat if charging and thermal control are not properly managed. Therefore, the histogram does not only describe battery performance but also provide insight into potential factors contributing to battery overheating and fast battery drain. Thank you.
Hello again. So now I'll be talking about the cause and effect diagram. This fishbone or Ishikawa diagram shows the root cause analysis for poor battery performance in ABC electronics smartphones, which mainly includes battery overheating and fast battery drain. The causes are grouped into 6 main categories. First, under material, poor battery performance is caused by the use of low quality lithium-ion battery cells and high internal resistance, which lead to excessive heat generation and reduced energy efficiency. Next, under method, the issues include poor thermal management and heat dissipation, as well as inefficient charging and power management methods, causing the battery to heat up and discharge faster than expected. For machine, unstable charging control circuits and variations in battery assembly equipment contribute to inconsistent battery performance and charging failures. Under measurement, there is inadequate inspection and testing of battery performance, along with limited detection of internal battery defects, allowing faulty batteries to pass quality control. In the man or people category, improper handling during assembly and testing, and a lack of awareness of battery safety procedures increase the risk of damage and defects. And lastly, under environment, high temperature during storage and operation, as well as improper storage condition, accelerate battery degradation and reduce lifespan. In conclusion, the diagram shows that poor battery performance is mainly due to a combination of material quality issues, design and process weaknesses, equipment variation, and insufficient quality control. Addressing this root cause can significantly reduce battery-related defects and improve overall reliability. Thank you.
Hi everyone. So today we are looking at the root cause behind our recent battery performance issue. To ensure the comprehensive fix, we have categorized our finding into the 6M framework: material, method, machine, man, environment, and measurement. Let's walk through the key cause and our proposed countermeasure for each. The first one is the material and method. This is the core process. First, looking at the material, we identified that low quality battery cells are entering our line. To fix this, we are tightening our supplier selection criteria and implementing a more rigorous incoming material inspection. So now we are moving to method. We have found our current thermal and charging management protocol aren't sufficient. We will be optimizing our charging procedure and redesign the heat dissipation path to keep the units within a safe temperature range. So on the machine side, the unstable charging circuit have led to our inconsistencies. Our countermeasure here is a strict regular calibration schedule for all charging and assembly equipment to ensure output remains steady. Regarding man or our personnel, improper handling was a noted factor. We are addressing this through a comprehensive battery safety training and rollout of updated standard operating procedure (SOP) for every floor technician. Next is the environment. High storage temperature are degrading the battery before they even reach the customer. We are implementing a climate control storage solution to stabilize this condition. Finally, for measurement, we realized our testing phase was inadequate for catching edge case failure. We are staggering our end-of-line inspection and a defect monitoring system to catch an error before they leave the facility. So by addressing these 6 pillars, we aren't just fixing a symptom, we are hardening our entire production ecosystem. Our goal is to move from a reactive state to a proactive one, ensuring the highest level of safety and reliability for our products. Now, let's look at the impact of those changes on this C chart, which track a daily smartphone battery defect. The goal of this chart is to monitor our progress against our established control limits. On day 1, we start with a high over 30 defect, which was near our upper limit control of 33.15. However, as the countermeasure were implemented, you can see a steady downward trend by day 3. We successfully dropped to the average center line of 19.8. The most critical result appeared on day 5. We saw the defect count drop to approximately 4, which is officially below our lower control limit of 6.45. This indicates a significant improvement in our progress. This data confirm that our 6M strategy is working, and we will continue to monitor this level to ensure a new standard of quality is maintained. Thank you.
For the standardization stage, the goal is to make sure the improvements are maintained and consistently applied. First, ABC Electronic develop and document new standard operating procedure for battery, storage, testing, charging, and assembly. All of these approved procedure were then recorded in the quality management system so that everyone follow the same standard. Next, operator were trained on proper battery handling and safety practice to reduce mistake and improve awareness. The company also scheduled regular equipment calibration and preventive maintenance to ensure machine perform accurately and reliably. To monitor the process, control charts were introduced so battery performance can be tracked continuously and abnormalities can be detected early. Routine quality audits are carried out to make sure procedures are followed correctly. Communication between the quality team, production, and supplier also strengthened, so issue can be solved faster. In addition, detailed records are kept for traceability, allowing quick identification of problem if defect occur. Finally, the SOP are reviewed and updated whenever improvements are made, so the system keep getting better over time. Through this standardization process, ABC Electronic is able to maintain consistent quality and prevent defect from recurring. To conclude, the 7QC2 help ABC Electronic analyze the problem in a structured way. The results show that battery overheating and fast battery drain were the main contributor to defects. By identifying the root cause and applying targeted corrective action, the company was able to reduce defect rates and improve battery reliability. Once the improvement were locked into the standard procedure, customer complaint decreased and the production process became more stable. Moving forward, continuous monitoring and ongoing improvement are necessary to sustain this result and support better product quality in the future. That's all for me. Bye bye.